Hello and welcome back. Training a machine learning model is kinda like parenting in the digital age. Too soft, the model flunks like it skipped classes. Too strict, it crumbles like a student at a surprise viva. Today, we are diving into the drama behind underfitting and overfitting. Why a model acts like a clueless toddler or a stressed out topper. And guess what? We'll fix those model tantrums using tools like regularization, cross validation, and the avengers of machine learning, that is, assemble learning. Oh, and yes, we will meet the nerdy legends like Gini index and information gain, fighting for the best split in the land of decision trees. So, buckle up, future data scientist. This is gonna be one spicy, bite sized journey. Let's go. First things first, what is underfitting? Underfitting happens when your model is too simple. It doesn't capture patterns. It's like trying to explain a complex novel with just emojis. This can happen when you use a weak model, like trying to fit a straight line through a curvy dataset. Or if you stop training too early, like dropping out of college after 1 week only. So how do we fix this underfitting? To fix it, we try a better model, give it more training time, or feed it better features. Think of it like tutoring. Sometimes the students just needs better notes. So next we will learn about overfitting. Now meet this overfitting. This model is too smart for its own good. It memorizes the data like a parrot, but learns nothing. It's like during training it's a rock star, but during testing it crashes and burns. Now what this generalization term is, it refers to the performance of the model. Now whenever we are giving any cleaning data, passing the model, okay, fitting that into that, and whenever we are passing the some of the data for model to learn, then how well it is being trained, okay, that we can perform it by giving it some tests, right? So what tests are those, and what is the output result that on the unseen data, if that model is performing good or not, that term is known as generalization. Okay, next we will know about regularization. Okay, regularization helps us tackle high variance and prevent overfitting by adding penalty term to the model's loss function. Now let's break it down with two major types of regularization, that is L1 and L2. Okay, L1 is known as lasso. Think of lasso as a super tight elastic band that pulls some features all the way down to zero, like cutting unnecessary threads from a triangled sweater. Lasso is great when you suspect only a few features matters and you want to eliminate the noise. Next is ridge, L2. Ridge is like a gentler elastic band. It doesn't kill features, but it pulls them towards zero, reducing their impact but keeping everything in a play. If you want to shrink your model rather than delete features, then this is your go-to option. Now let's learn the next term, that is cross validation. It is another secret weapon against overfitting. This is like running your model through a series of tests, each with different data sets, to make sure it's ready for anything. No more one and done mistakes. So what this cross validation actual is, cross validation is a model evaluation technique that helps us better understand how well a machine learning model will perform on unseen data, that is data it has been trained on. Or instead of splitting your data set just once into training and testing sets, cross-validation divides the data into multiple smaller subsets called folds. This model is trained on some of those folds and tested on the remaining ones. This process is repeated several times and the results are averaged out. The cross-validation techniques gives us a more reliable estimate of a model's performance, and it's especially helpful when the data set is small. If you want to take any of the example, then imagine you are baking cookies and testing only one out of the whole batch to see if they are good. Not enough, right? Cross validation makes you taste a bit of every batch before giving it a thumbs up. Now let's learn the next term, that is assemble learning. Assembled learning is a method where we combine multiple machine learning models, often simple ones too, to create a strong, accurate model. The simpler models are called weak learners, but when we combine them smartly, they become way more powerful. Like teamwork. Team is better than single person, right? The main goal of this assembled learning is to improve the accuracy, stability, and generalization of predictions. Okay, it helps us to fix the problems like overfitting, underfitting, and low model accuracy also. Now we know what underfitting is, what overfitting is, when a model is too overconfident, when a model is not that much good in performing, it has not understood the things, those overfitting, underfitting, and if the accuracy is not, then in that cases this assembled learning will help us. Okay, if you want to take a real life example, then cricket match, one commenter might say that the pitch is good for batting while other disagrees. But when you bring into the panel of experts, suddenly the predictions became more balanced and reliable. That's assembled learning. Now let's learn what are the different types of these assembled learning. There are two major types of assembled learning techniques, that is bagging and boosting. These sounds like boxing moves, I know, but they both are very strategic approaches in machine learning. So first learn about this bagging. Bagging, it's a short form for bootstrap aggregation. It is when multiple models are trained at the same time in parallel, okay, using different random subsets of the original data. We divide the data, okay, and then we create subset and then we train a model. So using different random subsets of the original data, each model makes its own different predictions. And the final result is calculated by combining all of those predictions, often using a majority vote for classification or an average for regression. So majority, here what thing is important, that is we are creating subset of data, we are creating different models parallel to each other, okay, and then all the results we are combining, and with the help of majority vote for classification we are making final decision. This technique is especially useful when your model is overfitting, okay, that is it's performing well on training data but poorly on the new data. So bagging reduces the variance in the model, making it more stable and generalizable. If you want to take any of the common example of bagging, that is random forest algorithm. What this random forest is, I'm going to explain it in detail, okay. If we are getting time in this video, then I'll explain it in this only. Which uses many decision trees. So what this decision tree is, that also you will understand in this example, in this video only, okay. Just have some patience. Each tree is trained on slightly different piece of the data, and in the end all the trees vote on the final output. Just for right now consider it as a tree, okay. Tree is having branches, nodes and everything. So here how we are going to convert that into data, how we are going to understand the thing related to our data or to machine learning, we will see those things. Right now what I want to do is I want to clear all theory first, whichever is required for models and building them. So I'm explaining the theory right now. So in bagging, a common example, that is random forest algorithm, keep this in mind, okay. You will need these things. Next is boosting. This is on the other hand. Boosting is all about learning from mistakes, just like life. Here, models are trained one after the other, and each new model tries to correct the errors made by the one before it. It's like elder child is learning, making mistake, and then he's getting punishment, and then the younger gets aware about it, right? This technique focuses more on the data points that were predicted incorrectly in previous rounds. So the model becomes more accurate with each iteration. Boosting helps reduce bias and is best used when your model is underfitting or failing to learn patterns in the data. So powerful examples of this boosting are like, it includes gradient boosting and XGBoost. What these all are, we are going to learn, okay. For right now, in this example, I think I'll cover decision tree and random forest, okay. Let's see up till when we have time we are going to complete it. Now let's come into some of the real life examples, okay. Let's bring it back to school for a second. Imagine you wrote an essay and it was graded by just one teacher. That teacher might be in a bad mood, or maybe they really love Shakespeare and you didn't quote him even once. Unfair, right? Now imagine your essay is graded by a panel of teachers. Each brings their own perspective and the final grade is an average of their judgments. It's fairer and more balanced. Assembled models works the same way. They take information from different models and make a final decision that's less biased and more reliable. So here what important thing is there, what is assembled learning? Assembled learning's types are bagging and boosting. In bagging we have random forest, in boosting we have XGBoost and those all things. Okay. Now let's move further that why we should use these assembled learning. Okay. Because assembled learning techniques improve prediction, accuracy, handles messy real world problems like are overfitting or underfitting, and is useful in everyday applications. From spam detection in your email to fraud prevention in banking to recommendation systems on your YouTube and Netflix. In short, assembled methods are not just smart, they are industry smart. So let's move on to our next topic, that is gradient boosting. Gradient boosting is a machine learning technique for classification and regression problems. Now what this classification is, what is regression, we know that all. It's a part of boosting family where the ideal is to combine multiple weak models, typically decision tree. Now decision tree only we are going to learn in boosting, so that is okay. Have some patience, then we will understand what decision tree is also. Into a strong model, okay. We are combining small weak models and then making a final strong model, okay. The gradient part refers to how it minimizes the loss function, okay, by taking steps in the direction of the negative gradient. Imagine you start with a dumb model, okay, that barely gets anything right. You're asking yourself again and again that where am I messing up? You know the errors, okay, that is known as residuals in this machine learning language, and train the next model specifically to fix those mistakes. Whenever we are making mistake, we learn something from that, and the next time we are not doing that thing. This is only life, right? So now repeating this process multiple times, each new tree focuses on the residual, that is errors of the previous one. Combining all the trees, you have got the model smarter with each step. Now what is advantage of this? We got high prediction accuracy, we handle missing values well, work with different types of loss functions also, we reduce biases and variances also. But there are also some of the disadvantages, okay. So disadvantages like it is slow to train, okay, if we are having large data sets. It is prone to overfitting if not tuned properly, okay. We need to make sure of overfitting and underfitting problems also. Harder to interpret than a single decision tree. Some of the real life examples are like credit scoring, spam detection, churn prediction, medical diagnosis, okay. What is this entropy? Entropy is a measure of uncertainty or impurity in a data set. Alright, data warriors. Let's say you are building a decision tree. You have got questions, features, and a burning desire to split stuff up. But how do you choose the best feature? You call in the legends, that is information gain and Gini index, and let them battle it out. First in the ring, we will learn about information gain. This pranic uses entropy. Now what this entropy is, we have understood, right? Which is just a fancy word for the chaos. In our data, something is impure, then we will say it is chaos only, okay. If your data is all mixed up, yes, half no, entropy is high. But if you split your data smartly, entropy drops and boom, you have gained information, right? It's like cleaning your messy room. The more junk you sort out, the more info you gain about where your stuff is. Now there enters the next term, that is Gini index. It is smooth and calculated. He doesn't care about entropy, okay? Here is all about misclassification risk. He asks, if I randomly assign labels, how wrong would I be? Lower Gini, better split, less risk, more confidence. Both love pure, clean data. Both want this perfect split, but there's drama. InfoGain is sometimes biased toward attributes with many categories, whereas Gini, it is less biased, but not always as mathematically deep. So now what this decision tree in actual is? It is a question. Now decision tree is a supervised learning algorithm, fancy name, okay, but it is simple logic. It is used for both classification like spam versus not spam and regression like predicting house prices. So now in the previous videos we were learning about logistic regression, linear regression, and we understood about their examples. Okay, we were having multiple linear regressions also. Those things were there. Okay, now we studied each of them examples, okay, with small practicals. Okay, we understood those things. But now here what this decision tree is doing, it is both the classification and regression terms both are combining. We can work with this decision tree and we can gain the access of both of the classification and linear regression. So which one is better? Decision tree is, right? But we need to understand this decision tree also in depth. Okay, so we'll learn this now. Now imagine it like a flowchart with yes or no questions. Each internal node, a question is there. Each branch, a possible answer. Okay, I'll show you example of decision tree only. So here you can see that this is type of decision tree. Okay, this is we are going to split our data into. Okay, so each internal node, it is a question. Each branch, it may be a possible answer, and each leaf, the final results like yes, buy the product, or no, don't buy it. So it's basically a choose your own adventure book for data. If you want to say any of the real life example, then let's say we are predicting whether someone will buy a phone or not. First question is their age over 30? Yes, cool. Next day, do they earn over 50k? Yes, great, probably a buyer. No, maybe not. And so the tree grows questions by question until we get an answer. There are some of the key terminologies that we should know about this decision tree. Okay, we have root node, it is the starting point. Okay, it is the trunk of our decision tree. Then we have leaf node, it is the final decision. No more splitting, no more drama. Splitting is done. Okay, basically the gossip that splits the group chat. We have branch, a path from one question to the next question. Decision node is there. Okay, a point where question is asked, and we have pruning also. Now what this pruning is, we are going to learn it into depth, but still cutting out unnecessary branches like toxic friends in 2025. Okay, but why is everyone obsessed with this decision tree? Here's the tree. It is easy to understand even if you are not a data nerd. It's like that one friend who can handle both a breakup and a group project, reliable, adaptable, and little dramatic. Okay, let me explain this pruning techniques a little bit. Trees can get too excited, okay, splitting left and right like there is no tomorrow. But too many splits, overfitting. So we use prune, claim things down. Pre-pruning, set limits from the start. Post-pruning, build the whole tree, then chop the weak branches. If we want to take any of the real life example of this pruning, then let's say we are building a model, okay, to predict illness based on symptoms like fever, cough, and fatigue. The tree asks, does the patient have a fever? Yes. Do they have a cough? Yes. Then probably they are sick. If no, maybe they are just tired of Mondays. Who isn't, right? There are some of the advantages of this pruning and disadvantages. Okay, it is simple, flexible. There is no scaling needed. Okay, it can handle complex relationships also. And some of the disadvantages are like it overfits easily. Okay, it's sensitive to small changes. It can get messy with the large data also, and might be biased toward features with many categories. We still pair it with random forest or boosting, and it's basically Iron Man in the Avengers. So now project time. Okay, so let's open a Jupyter notebook, create a new file, import some of the libraries, and let's start. So here what I have did is I have imported the libraries which we were needing. Okay, so now what these libraries are and how we are importing, why we are importing them, this thing you all know, right? So we have took pandas, then NumPy, then Matplotlib, Seaborn, and from scikit-learn, that is machine learning's library. Okay, we have took decision tree classifier. Okay, from that plot tree also we have took. Then from model selection, it is for train test split. Now what this train test split is there, how we are writing it, we have learned it in the previous videos. Then from scikit-learn.matrices, we have imported accuracy score and classification report. These terms also we have learned in our previous videos. If you have some questions regarding them, then you can ask me in the comments. Okay, now why every time I am creating sample data sets? Because okay, I have explained data cleaning. Okay, I have created videos on that. Okay, If you have watched those videos, those were focused on that part only, that was data cleaning. Here what I want to tell is I want to teach you a decision tree. Okay, so my main focus is going to be on that. So why I am taking sample data set? Because this data set is being manually created by me, so that is why there is no need of cleaning or organizing the things. Okay, I know what is there in the data, okay, how this data is there. So understanding and cleaning, these two steps are being skipped in this part because we have created the data manually as per our understandings. Okay, and we also get the idea that how is data being created, so that is why I am always taking data manually only. Okay, and these are the rough things. Okay, these are not the actual data sets, but in real life we are going to take files, right? From different sources we are going to connect files. So what I have did is I have created this sample data set. Okay, in that I am having age, gender, estimated salary, and purchased means if they are buying it, then it will be 1 or 0, and if they are not buying, then it will be like that. So I have told over here that is, and purchased means what? If they, here I have wrote it in the comment also. Okay, if 0 is there, then that means they have not purchased it. Okay, and if 1 is there, that means they have purchased it. Okay, it is just a sample data, no complex thing. Okay, it is easy to understand also, that is why I am not wasting much of the time on data sets. Okay, so that is why I am just creating sample data so we can understand things quickly, we can focus on the main thing, that is why. Okay, so what is we are having over here, that is age, gender, estimated salary, and purchased. Then what I have did is I have created a variable, and this data I have stored in that variable, that is df. Okay, and from that I have, in what type I have stored this data, that is data frame. Okay, then I am just going to print this sample data. Okay, this is the sample data set, so I am just going to print this sample data. So let's execute these libraries, then this data, and then this print our data. So you can see this is the sample data. Okay, in that I'm having age, gender, estimated salary, and these purchase things. In all we are having 15 entries. Okay, if you want to see, you can see the information range index is there. There are 15 entries. They have been indexed from 0 to 14. Okay, how much columns are there? We are having 4 columns. Okay, then see now here there is no empty values, right? So this is good thing. Then data type is there, integer type is there, object is there, integer. Okay, here we can see data types. Okay, integer types of, we are having in 3 columns integer types of value, and object, that is characters, that is text, means here this male, female, this column it is showing, it is having in one column we are having object type of data. Okay, simple clear things. If you want to understand your data a bit more, now as we have created it manually, so that is why I can just go directly with it. Okay, move further. So next what we are directly going to data pre-processing. Okay, we are going to learn data pre-processing. Now we are arranging our data, fitting our data into train, test, and building our data so that we can pass it. Splitting we should do, and then we can pass it to the model whichever we want. Now in this we are learning about decision tree, so we are going to pass for that. So done, this thing is done. Okay, we have misconverted that data, that text type data, object type of data. Okay, now what is there? Feature selection. Feature means like independent and dependent variables that we know what are there. Okay, so what we are going to do is we are going to take multiple values, and one thing, this purchase is a target in this thing, right? This is dependent on these all things. Okay, so these things, these age, gender, estimated salary, it will come in X, and this purchase it will come in Y. This is a target. Okay, defining X and Y, you can say that. Feature selection, you can say that. Okay, in short these all terms are that we need X and Y, and based on that X and Y we are going to split the data, right? So that things we are going to do. So I'll quickly write train, test, split also, and then feature selection also. Okay, so now we have done this feature selection in X. This is our independent variable. So in that I have passed age, gender, and estimated salary. Okay, clear this thing. Then what I have did is Y variable I have declared. Okay, Y variable, in that target what is there? Purchased is their target, so I have passed it there. Then now we have got this X and Y, so we are going to split our data through the train, test, split. Okay, how we are writing train, test, split, we know that. What it does, that also we know that. X and Y is their test size. It is means we are passing 20% of our data to machine. Okay, so that machine can be a machine can test on that data, whatever it is going to learn, that the rest of the 80% data is there, which is for training. So it can use that data and learn the things. Then after learning, we are passing that this percent of data is there. You have to test the things. You have to give your exam and pass that test. Okay, so 20% of data is there for the testing purpose. Okay, we have done that thing. Now next step is there, simple. Every time in every model there is the same steps are there till we are defining the model. Okay, so what now, and even though after defining the model, we need what we need to do is, now that model is being trained. Okay, so what we have to do is we have to take test of that model. Okay, testing purpose is going to be, and then if it is going to perform accurate, then it is good. If not, then we have to again go in the previous steps. So model selection, now we are learning decision tree, so we will do with that only. So now let's see if our model is being okay or not. Decision tree classifier I have took. Okay, criterion, entropy and random state, you all know now what it is. Okay, then I have fitted into the X train and Y train. Okay, now let's execute. So decision tree we have took. Okay, we have told the model that use decision tree and learn the things. Okay, learn. Now let's test our model. So we have created this new variable, that is ypred, what is y prediction. Okay, and when we have passed the testing data to it. Okay, next now let's see evaluation. Let's do the evaluation things. Evaluation, what I wanted, that I wanted accuracy score and classification report. This report can help us to tell detailed information. Okay, that if it is performing good in actual versus predicted values, how we are going to get any differences or not. Okay, so that we can understand with this classification report. And accuracy, it is giving us 0.333, that type of accuracy. Okay, classification report, this evaluation, in that I have passed accuracy score, means I want to know the accuracy of our model. Okay, then I want classification report. In classification report we have precision, recall, F1 score, support. These all terms I have explained in previous videos. Okay, so we have got accuracy of 0.33. okay, infinite number is there. Then classification report, what it is telling is that for zeros we have this much values. Okay, for ones we have this much values. Okay, in a purchased, if there is 0, then precision is 0.50, recall is 0. All the things are there. Okay, support is 2. For 1, the terms are being given. Whereas accuracy, real accuracy, you can see that 0.33 and 3 support is there. Okay, macro average, weighted average, all the things are being mentioned. With the help of this classification report, we can understand things clearly. If you all want a detailed reading of this classification report, means understanding how to understand classification report, then also you can comment it in the comment section. Okay, because I feel that this classification report you might have not understood in depth. Now let's see whatever things we have did up till now, are though accurate or not. Now let's make a visualization and understand things. Okay, so we are going to visualize a decision tree, and this is the final step. Okay, then we will understand that how to read the decision tree. Okay, what it is going to show in actual, that if this project is there, what it is telling us. Okay, here what I have did is, in the final project we are going to solve the errors also, whichever we are getting. Okay, here I am telling that how it is being created. Okay, here I am not going in depth for the accuracy. Okay, so here just our main motto is there, we have to understand the things, and in the final project we are going to work with all the terms. Okay, like if there are any errors, if in this classification report some of the things are not accurate, then we have to go back, then solve them, and again come how to read the classification reports and all the things. Okay, in the final project. So let's focus on here visualization. We know how visualization is there. From matplotlib figure we have took figure, what it will tell us, it will define the size of that figure, whatever visualization we are creating. Okay, you can increase it, decrease it. Okay, plot what we want, tree model we wanted, and as we are using matplotlib only, so we have to give the detailed information. Okay, field, it is true, feature names are like X columns, classes, what we want to, what is a target, like purchase and not purchase is there, that is why we have given those class names. Also title, what it will be, decision tree. Now as we are building the project, that will they buy a mobile phone or not, so that is why I have given this name to this, and then plt.show, we know what it does. So let's execute this cell. So you can see this decision tree is being created over here. Gender, then it has categorized, means like gender is smaller than equals to 0.5. then what is this, entropy? Entropy is impurity in a data, right? Then samples 12 is there, value for 8 is there, means like for a female, male, so like that it has categorized. Okay, and class, purchased or not purchased. If purchased, then true. If not, then false. It is going, and then again it is showing some of the things, then again it is dividing it, then again. So like that it is there. Okay, this decision tree we have formed. Now how to read this decision tree, what we are getting from this decision tree, let's understand those things. So root node, we know root node is the trunk. Okay, means it is the starting one. Okay, so this tree starts by looking all the features and asking which feature splits the data best into zeros and ones. Okay, it uses a concept called information gain, we have known what it is, okay, to decide which feature reduces the messiness of the data the most. Then we split the data into left branch, that is age is less than or equal to 35, then right branch, this age is greater than or equals to 35, like that. Okay, then each of these two groups now become a smaller data set. Again the tree asks which feature should I split this group on. So let's say in the left group it decides like estimated salary, okay, which is less than equals to 30. So like that this data is being splitting, it keeps doing this, checking every feature and continues to split until one of the stopping conditions is met. Now when does this tree actual stop? Because pure leaf, okay, this pure leaf is there. Okay, all examples in that node belong to the same class, that is zeros or ones. Max depth, we will pass max depth also. Okay, you can set a maximum number of split like 3 levels or 5 levels also. Minimum samples, if too few samples are left it may not split further. And if no gain, if the split doesn't improve information gain, then it will stop by itself only. Okay, now let's break it down, that this estimated salary is all like, okay, all the blocks, okay, all the nodes we will say of this. First we are getting this estimated salary. Okay, then entropy is there, then samples, value and class. Now let's break it down in detail. Estimated salary, first thing, that is feature used to split. Okay, it is the feature that is used to split the node. Then entropy, how mixed the data is, like 0 is there then it is pure, and if 1 is there then it is completely impure. Okay, so it has not given proper 0 also and proper 1 also, right, in some of the cases. So here entropy is 0, entropy is 1, like that. Okay, here also entropy 0 is coming, sample is 1 is there, means no more thing is there for splitting. Okay, samples, how many data points reach this node. In this there are two nodes which have reached. Okay, there are two data points which have reached this node. There in samples here are 3. In samples you can see only one node and only one node. Okay, means there is like one value is there, one person is there from male or female. Okay, is purchased and one value is there. Okay, value means like how many zeros and ones. Example, 6 not purchased is there and then 4 is purchased is there. Okay, so here you can see values is there 0 and 7, means 0 was for not purchased, right, and 1 was for purchase. So 7 are there, those who have purchased. Here 4 are there, those who have not purchased. Means like if their salary is 27,000, okay, or equals to or greater than, like that is there, then 4 of them are like that those have not purchased, right. So majority is not purchased, so class is this not purchased. Okay, then it is dividing further, like that is there. Then class what is telling, it is predicting the outcome, okay, of that node, majority vote. Here also what is there, majority vote means most of them have purchased. Okay, this is coming into this class. Here if you can, this number is higher, so not purchased is here, also not purchased is there. Here both are equal, so not purchased class it has been divided because some of the factors are also there. Okay, above factors are also there because this is highest here. Then here what it has done, here this purchased one is there and here not purchased one is there. Okay, so this is how we are reading a decision tree. Now let's take some of the real life examples so that you can understand it. We are taking this only example, that mobile phones example only. If the person is about 35, yes, do they earn more than 50k? Yes, okay, very likely to buy. And if no, then probably not. Maybe sometimes a person wants, person don't want, like it depends on moods or even the conditions, right. That's literally how a decision tree thinks. It split people into categories using yes, no, gates until it makes a prediction. Okay, so what is advantage and disadvantage of this decision tree? Let's discuss some of the advantages. Okay, it is easy to understand. Okay, visual and interpretable. Okay, we have visualized it. Okay, and we can understand things in better now. Okay, there is no need for feature scaling. Okay, let's discuss some of the disadvantage of it. It can overfit if too depth. It can overfit if to depth. Okay, not great with small changes in data, unstable. Okay, less accurate. It is less accurate compared to assemble models like random forest. Here is a tip for you all. Okay, to avoid overfitting, we can prune the tree, cutting off unnecessary branches like trimming a bonsai. That keeps it simple and general. So what did we learn today? Your model isn't just a bunch of numbers, it's a vibe. Treat it right and it won't just memorize, it'll understand. Whether you are battling underfitting like a bored student or overfitting like an anxious perfectionist, the key is balance. Throw in some regularization, test it with cross-validation, and let's assemble models, run the show like a talent squad. And when it comes to decision trees, split smart. Prune the noise and let the Gini and information gain do their dance. Got questions? Drop them in the comments like hot potatoes. Don't forget to like, subscribe and hit that bell so you don't miss anything regarding this machine learning series. Until next time, stay curious, stay caffeinated and may your accuracy always be high and your loss delightfully low.